In screencast 20.13, we ask ourselves what will happen if you take some bromine and add it to a solution that contains both table salt, that's sodium chloride, and iodized salt, sodium iodide, at 25 degrees Celsius. We assume everything's in its standard state. That way we can look up standard reduction potentials to see what's going to happen. First, you should recognize that this is not an electrochemical cell. This is simply two single replacement reactions, and we're wondering which one will proceed in the forward direction, for which standard reduction potentials are very useful, right? If it's positive, it will go forward. So here's one possible reaction where sodium chloride plus bromine will form sodium bromide plus chlorine, or for the other one, sodium iodide plus bromine turns into sodium bromide plus iodine. And so what's happening? Let's take a look. Bromine is turning into bromide, therefore it's getting reduced. Chloride is turning into chlorine, it's getting oxidized. And in this case, it's the same thing, only the iodide is being oxidized, losing electrons to turn into iodine, and the bromine is gaining electrons to turn into bromide. So we can write down each half reaction. Chloride to chlorine, bromine to bromide. Let's try this one, iodide to iodine. That is our oxidation, bromine to bromide. And we look up the standard reduction potentials for each. And we get values of, as shown here. Now, the nice thing is, since we've written down two standard reduction potentials, we just take the difference. We don't have to worry about what order they're in or anything like that. And you can see that this one's going to be positive, meaning that's the reaction that will happen in this forward direction. This would go in the other direction if you mix them. And therefore, this is the reaction that will occur. And we can solve this using what's known as the diagonal rule, although we already did solve it. I would always just do it this way. And one thing to point out is that don't double this value. Don't double this value for redox reactions like this. When we look up standard reduction potentials, the coefficients do not matter. You can take a look at these three values. To me, what we're trying to show here is that as you go from iodine to bromine to chlorine, and in fact to fluorine, the reduction potentials get more and more favorable. And that's not surprising. I think of that as following a standard electronegativity trend, fluorine being the most electronegative, highest desire to gain electrons. Another way of looking at this that may not be clear in the beginning is that the bromine can oxidize the iodide, but it cannot oxidize the chloride. Best way I think to look at it is just to do these two values and say, yes, this is positive in this direction. This is Screencast 20.13.